So the primary signal is picked up by the receptor. Then the receptor connects to the processor protein. And then the processor connects to the effector protein. And that sends a secondary signal to the protein pathway. Okay, now I will show you a video of how it works. This is the receptor with an antenna. This is the processor. Look at the shape and look at the shape. They don't connect. Signal comes, changes the shape. This hooks to this one. This one sends the signal into the cell. When the signal goes away, the shape goes back and the switch is broken. This does not fit. But now the primary signal changes the shape. And then this changes shape and sends a signal in. And this signal controls the function, a specific function inside the cell. So this is how a switch works. Okay. In the new biology, they talk about this is the cell membrane, and the signals come from the environment, binds a receptor, and then the effector sends signals in to control proteins. And at the end, you get behavior. So signal causes behavior. These pathways, there's a new field of science, and it's called signal transduction. And there are thousands of these different pathways. Okay. The name of the protein in science talk is complicated. It's called a receptor effector integral membrane protein complex. But I will show you there was a name for this switch for over 1,000 years. And I'll use the definition, and then I'll show you the word. The function of the receptor is awareness of the environment. Like eyes, ears, nose, gives you awareness of what's going on. The function of the effector is to send a physical signal into the cell. Or I'll call it a physical sensation. So the definition of the switch is awareness of the environment through a physical sensation. Now in the dictionary is the word perception. And the definition of perception, awareness of the elements of environment through physical sensation. What is the name of the switch that controls your biology? Perception. And why that's important is that it's you and how you see the world that controls the biology. So conclusion number one, perception controls behavior. And what causes behavior? Yes. Oh,
Yeah,
the
signal.
physical part. The protein. So the signal, the switch, controls the protein, which is the behavior. Okay. Now, we did not talk about DNA. When you need a protein in the cell and it's not there, then you need the blueprint, which is the gene. So how does it work? I get very excited because I'm going to show you how a gene works. But before I do that, I want you to know that we have been given misinformation. When people say a gene turned on and a gene turned off, it sounds like the genes make decisions. Here is the simple truth. A gene is a blueprint. So if you go to an architect office and he's working on a blueprint and you lean over his shoulder and you say, is your blueprint on or off? And he goes, that doesn't make any sense. A blueprint cannot be on or off. It's a blueprint. A gene cannot be on or off. It's a blueprint. The truth is, are you reading the blueprint or are you not reading the blueprint? And the gene does not make that decision. So this is how it works. In the nucleus of the cell are chromosomes. The chromosomes are units of heredity. And the chromosomes are made out of 50% DNA and 50% protein. What does the protein do? And the answer is, for 50 years, we did the experiments. We isolate the DNA and throw away the protein. And some people a few years ago said 50% is a lot of protein to throw away. What is it doing? And the answer to this question will change civilization. And I'll tell you why, and the answer is because when you understand how the protein works, you understand that you control the genes do not control you. A chromosome is a DNA core with a protein sleeve. Pretend my arm, my bare arm, is DNA. And I write with a magic marker a genetic code for blue eyes. And I say, can you read the gene for blue eyes? I say, what does it look like inside the cell? Can you read the gene for blue eyes? If you want to read the gene, what do you have to do first? Take the sleeve off? What's the sleeve made out of? And what causes the protein to change shape? The signal. Okay, so this new science is called epigenetic control. Before in school we teach genetic control, which simply means control by genes. Epi means above, like epidermis. Okay, so epigenetic control says control above the genes. Now I will show a video how it works. Very simple. Okay, the chromosome is DNA core with protein sleeve. At the beginning of each gene is a protein called a regulatory protein. The signal binds to a specific protein. The protein sleeve comes off, and then the DNA is exposed. Then a device will come up and make a copy of the gene, and this is the blueprint used to make the protein, RNA. And the signal comes off, and the gene is covered up again. Okay, now watch with fast. Signal from the environment selects a specific gene, sleeve comes off, the RNA, you make a copy, DNA, RNA, and goes to make protein. And then the sleeve comes back on. Now this time, let's see what the DNA did. Come on, DNA, do something. Come on, do something. Do something. Nothing. The gene does no control. The gene is never on or off. The gene is read or not read. And what do you think controls the signal? Perception. Okay? Now, so this is the same kind of signal transduction. And so the receptors are the input from the environment. Then the signal travels through the proteins. It goes to the nucleus and affects the proteins of the chromosome. And then the copy of the gene is made, and that's the output. You are not the victim of your genes because you control your genes. One gene blueprint using epigenetic control can make 30,000 different proteins from one blueprint. So you can come with good genes, and then through epigenetic control create cancer, diabetes, and it has nothing to do with the genes but epigenetic control. So you can come with good genes and make mutant products, or you can come with a mutant gene and become normal. I'll show you. This mouse is a mutant mouse, a goody mutant, blonde, fat, and diabetic. This is a normal-looking mouse. It's a normal-looking mouse because it's a goody mutant. The difference, when this was in gestation, in fetal development, the mother was fed these additives, and these affected the epigenetic control and covered up the mutant. So you can have mutant genes, but with epigenetic control, you can act and become normal. One more example. Okay, this is a mutant mouse called Kinky Tail. This is a mutant mouse, same one, normal tail. What's important is Kinky Tail is the same mutation in humans that causes spina bifida. And this gene can be covered up with epigenetic control. So you're not the victims of your genes because you can change any of your genes anytime. The following is a quote from the scientist who did this. Both nature and, I think it's written, so both nature and nurture are important and both are intertwined, but what's bigger is epigenetics in terms of bulk. Genomics might be the tip of the iceberg, but epigenetics is the base. Medicine has some information about this, but it doesn't have very much about the bigger thing called epigenetics. When this becomes known to the public, it returns responsibility for your health to you, and you are not a victim of your genes. And recently, it is becoming more public. And the recent issue of Discover, DNA is not your identity. Yet every day, the media still tells you that genes control this and genes control that. And then people get nervous about what genes are in their family. And as Greg Braden said before, if you look for the disease, you can create the disease through epigenetics. Right now, it appears that about 95% of cancer is not because of mutant genes, but because of epigenetic control. And it can be passed from parent to child like genes. But the difference is you can change your epigenetics at any time. So the central dogma, DNA, RNA, protein, primacy of DNA, is not complete. Put in the protein for epigenetic control. But the protein is controlled by the signal, which comes from the environment. So it's not the primacy of DNA that's in the middle. It's the primacy of the environment. Number 2, perception, the switch, controls the activity of genes. If you change your perception, you change the reading of your genes. If someone tells you you're going to have a disease and you believe that, then you can create the disease. So there are 3 conclusions because I don't have enough time to talk about one, but I will list them. Okay, conclusion 1, perception, how you see life, the switch, controls behavior because that's protein. Perception controls which genes are being read and how they're being read. And the one I didn't have time for right now is the 3rd one. Perception can rewrite the genetic code.